this is a production Mercedes car. It's using our NVIDIA Hyperion Drive sensor suite. So we have 10 cameras around the car. We have 5 radar.
And then radar means LiDAR.
No, not LiDAR. Just the normal radar.
Radar.
Yeah, radar. And then 12 ultrasonic sensors that we use for parking. Okay.
Wow.
And then for compute, we have one Orin, a single Orin.
Yes.
One Orin X. And then the software stack. This is using the Alpamayo end-to-end model, as well as our classical stack in parallel. So the way to think about it is Alpamayo is in the driver's seat. Alpamayo is doing 95% of the driving that you see, right? And then the classical stack is sitting in parallel, coming up with its own trajectories and comparing that with Alpamayo, and can step in to make sure that there's a safety guardrail there, right? So you get the best of the end-to-end model where you have the human-like driving behavior, and we're engaged, so you can see Kevin here will occasionally just touch the wheel just to let the car know that he's here. This is a level 2++ system. So the driver is still involved, right? So if he wanted to, he can collaboratively steer. If there's a pothole on the ground or something like that, he's able to move the car around it. He can also request a lane change using the turn signal stalk. But from here through the end of the drive, the car will make all the decisions. So stopping for the traffic lights, the braking distances, making lane changes to follow the route, all that is done and controlled by the car. So you can see we're approaching the red light, we're stopping behind the car here, right? We put our turn signal on to indicate that we're going to make a right turn, right? And the rest of this will all be done by the system. So it's a mix of both. So the base driving data is from human driving data. So for example, Kevin's one of our data collection drivers. His driving has been included in this model as an example, right? But then on top of that, then we add the simulation data for different weather conditions, different scenarios, right? New pedestrians, you know, things that maybe are difficult for us to find in real world testing, to find the long tail, right? And then that comes together in a model, and then we generate about 7 models per day that we then can test. And then through our evaluations, we then can update the model regularly. So the pace in which we're innovating is very fast. And because we have the classical stack underneath, right, it always keeps us kind of safe, so we can push the model quicker and move the development faster while still ultimately having that autonomous. Yes. So there you can see it's a crosswalk. So the car will slow down and be cautious because it cannot see with the large truck, right? So it wants to be slow, and then once the car can see around the truck, okay, I can go ahead and proceed. So yeah, so you can see we're stopping here. Coming up, we're going to have a left turn, right? So when we're making the left turn here, we need to look for people in the crosswalk, right? So the car is able to check for that, and then it'll make the maneuver once it's. So that was a right turn on red, so the car needed to creep forward so that way it could see, make sure there's nobody coming, and then it went and proceeded. They also use the HD map, so they understand you know, how the lanes, right? So with HD map, you know, this is a right turn lane that's 2.2 meters wide. This is a bicycle lane that's 1.5 meters, right? So you get very detailed information on the road infrastructure. Yeah, it's okay. So then, so that's the Waymo style, and then with Tesla, their approach is only with camera, so a little bit of a different style. And then for our stack, we use no LiDAR for this product, but we use the camera and radar. So 3 different ways to approach the problem, but it really depends on the design intent, right? So for us, for a level 2 system where the driver is still involved, right, we believe you're able to do that with the camera and radar, right? Because ultimately, we still have Kevin, right? But for the L4 initiatives that we're working on, which you'll see in the next coming year, right? That's where we want the redundancy with the added LiDAR for our approach.
Okay. And end-to-end.
Yes. So the way we like to think of it at NVIDIA is we want to enable the ecosystem of autonomous vehicles, right? So we have our simulation, obviously, right? That you can use, or partners can use, right? We have obviously our accelerated compute. So Waymo, for example, will use our accelerated compute to help train their models using the GPUs. Excuse me. And then we have our own software that we're deploying, which you're experiencing here, right? So you have hardware, you have simulation, and you have the software. And partners can choose to take some or take it all, right? It's totally up to what they want. We're agnostic to, for example, different vendor types, right? You can use different camera suppliers, just so long as you're using our specification we define, right? So the architecture is scalable from level 2++ to level 4, depending on what the partner his goal is for that product.
Okay. Oh, I see.
All the hardware on this car is all from, so you can see this guy was there. We had to brake, So we brake, right? Obviously he's coming in. All we change is we put an updated software build, but the hardware is production. This customer could go buy this car today, and then with over-the-air software updates, this feature then could be enabled. And then as we make enhancements to the model over time, right, they'll continue to be able to receive updates, right, for this Mercedes car. But any of our partners can choose how they want to do their own deployment and their cadence for when they want to update their models.